Hello and welcome to Otten Math. In this edition of Otten Math, we're going to continue on with our discussion about transformations. Specifically, we're going to talk about reflections. All right, so our objectives are to understand the basic vocabulary for transformations and for reflections. We're going to reflect any point over the lines y is equal to x, the x-axis and the y-axis. Now, as an extension, we'll talk about briefly, and I'll show you an answer, reflecting any point or object over any line of reflection. We're going to use our example for reflecting over the line y is equal to x and understanding this mathematically in order to help you to solve this problem. And then we're going to find the line of reflection given two sets of reflected points, both the image and the pre-image. Okay, so just back to talking about transformations. Transformation is an operation that maps or moves points of a geometric figure in a plane. Reflections, translations, rotations, and dilations are all transformations. Isometry is a subset or a grouping of these three transformations: reflections, translations, or rotations, because the same size and shape of the figure remain. So in a dilation, the size of the figure is going to change. So iso means same, metric measure, same measure. Reflections, translations, and rotations are isometries. We're going to talk about reflections today. That's an isometry. All right, so reflections. Reflection is a flip or a shape over a line of reflection. So here's a line of reflection, and I'm going to flip, let's just say, the right-hand side to the left-hand side. And the line of reflection ends up being the perpendicular bisector of all the segments that connect all of the original points, the pre-image, to the image. So if I were to take here, let's say, point A, and I were to reflect it over the line of reflection. So here's my pre-image, and I reflect A over the line of reflection to A primed. Here's my image. And I were to draw a line that connects line segments A to A primed. I know that the line of reflection is the perpendicular bisector of this segment A primed, which means that this point here is the midpoint. This forms a right angle. And then I know if the slope of AA primed is m, then the slope of the line of reflection is going to be -1 over m. All right, so perpendicular bisector of the line segments joining the pre-image and the image for all the points that are being reflected. All right, so that's reflection. All right, so now I want you to reflect this triangle ABC over the x-axis. I'm going to ask you to do this by intuition, and then we'll come back to this and work this process out mathematically. So I'm going to pause here. All right, so you should get A primed 1, -1, B primed 3, -4, C primed 5, -2. All right, so what did you notice? All right, so xy now becomes x -y as you reflect any points over the x-axis. Okay, so now let's go in the other direction. Let's reflect over the y-axis. I'm going to pause here while you figure this out. All right, so A prime becomes -1, 1, B prime -3, 4, C prime -5, 2. And again, what do you notice? You should notice that now the sign for x changes and y stays the same. So if you reflect over the y-axis, you're changing the sign for x. The value for y stays the same. All right, so now we want to reflect the triangle over the line y is equal to x, and I'll ask you to draw the line y is equal to x. So here is the line y is equal to x, and you're going to reflect these points over this line. So again, I'm going to ask you to use your intuition to see if you can solve this problem. Then we'll come back to this in a moment. So I'm going to pause here. And then I'll just remind you that there's a group project to have you find the coordinates mathematically. And I'm going to go through this in just a second for you. All right, so we're going to reflect 3, 4 over the line y is equal to x to end up at B primed. So B primed becomes from 3, 4 to 4, 3. C primed from 5, 2 to 2, 5. A 1, 1 stays at A prime 1, 1. All right, so what did you notice about this? Okay, so you're going to notice that xy, in this case, when we reflect over the y is equal to x-axis, we're changing the values for x and y. So xy becomes yx. All right, so let's go back to the group project that we talked about. I'm going to ask you to reflect B, which is at 0.34 the b primed and find b primed mathematically, not just by using the rule that I gave to you, or algebraically, I should say. And so what we're going to do is we draw the line y is equal to x. I'm going to identify this point 1, 1. So A is on 1, 1. And my equation for this line is y is equal to x. And I know that the slope for y is equal to x is 1. So I know the slope of the line b to b primed. And I don't know what b primed is yet. I mean, I do, but I want to prove this first. So b primed, b to b primed, we know is perpendicular to the line y is equal to x. So I know that the slope of b to b primed is going to be -1. So I can use a point slope form and the value that I know for b to create an equation. So y minus 4 is equal to -1 times x minus 3. And I'm going to rewrite this in slope intercept form by simplifying. Y is equal to -x plus 7. All right. So I know that y is equal to x in this case. So I'm going to substitute x in for y, and I'm going to solve for x. I'm going to add x to both sides. 2x is equal to 7. And then I determine that x is equal to 3/2. I know that y is equal to x, so y is also equal to 3/2. So I found this point of intersection here, 3/2, comma 3/2. And I know that 3/2 is the midpoint of b primed, right? Because we said that the line y is equal to x is, or the line of reflection is a perpendicular bisector. Remember we talked about that at the beginning of this discussion. So b primed, y is equal to x bisects and is perpendicular to b primed. So this point here is the midpoint. So given an endpoint and a midpoint, I can find the other endpoint, and that's what we're going to do. So the midpoint of b primed for x is going to be 3 plus the x prime value over 2, which is equal to 3/2. I'm going to solve for x primed. X primed ends up being equal to 4. The midpoint of b prime for y, 4 plus, we don't know, y primed over 2, and 4 I'm getting from the regular b value, not primed, the preimage value, is equal to 3/2. I solve for y primed, I get 3. And so I've just determined, given the midpoint, which I was able to find because the line y is equal to x is the bisector of b primed, and the original point, the endpoint, so the endpoint and the midpoint, I was able to find the other endpoint of the segment b primed, which is 4, 3. So that's mathematically or algebraically how we show that b reflects over the line y is equal to x to b primed. Okay, so moving on, I'm going to ask you to reflect these 3 points of the line y is equal to 2. I'm going to come back. All right, so you should get 3, 0, b primed, 5, 2 for c primed, and 1, 3 for a primed. All right, so reflect over the line x is equal to -1. I'm going to pause here while you figure this out. All right, so you should get -3, 1 for a primed, -5, 4 for b primed, -7, 2 for c primed. Okay, so now we're going to, I'm going to give you a set of points and I want you to write a rule. So I'm going to pause here for a moment while you figure this out. All right, so you're going to figure out that you can find the line of reflection using these 2 points or any 2 sets of points. In this case, we're going to use a and a primed, and we find the midpoint of a primed, and that's 1, -1, and then we find the midpoint of c and c primed is 5, -1. So you can see that the line goes through, just graphically and visually goes through the line y is equal to -1. So we need these 2 points, a primed and or b primed, c primed. So line of reflection is y is equal to -1, and the command would be reflect xy over y is equal to -1. All right, so this is an extension problem. I want you to see if you can reflect the triangle over y is equal to 2x plus 2. I'm going to show you the answer, but ask you that you do the work on your own. Think about what we did with the reflecting over the line y is equal to x to solve. All right, and the answers that I got, a primed -1.4, 2.2, b primed -0.2, 5.6, c primed -3, 6. I'm going to leave this process up to you to evaluate on your own time. All right, so next step is to find the equation for the line of reflection. We went through a process similar to this right when I showed you the 3 sets of points. So I want you to see if you can find the equation for the line of reflection here. I'm going to pause and then come back. Okay, so what we're going to do is we're going to find the 2 midpoints of BB primed and AA primed using the midpoint formula, -4, -0.5 for BB primed, and 0, 3.5 for AA primed. Okay, so the connection of these 2 points here, this line that connects, goes through both of these 2 points, and I didn't draw that line very straight, but this is supposed to be a line between these 2 midpoints. This is the line of reflection. I'll say it's a line of reflection here, and we're going to figure out what the equation for this line is, because that's what the objective is. So what we need to do is find the slope of this line. I'm going to use the slope formula. 3.5 minus 0.5 is equal to 4 over 0 minus 4 is equal to 4. So the slope is equal to 1. And I'm going to take this value and substitute it back in to this first midpoint. And you can put it into, or you can use either point, but I'm going to use this point for the midpoint here. And I get y minus 3.5 is equal to plus 1 times x minus 0, or y minus 3.5 is equal to x. I'm going to rewrite in slope-intercept form. Y is equal to positive x plus 3.5. All right, so that's how you find the equation for a line of reflection given 2 sets of reflected points. All right, that's it for this edition of Otten Math. Come back next time when we talk about, in chapter 16.3, when we talk about our last isometry rotations in the next edition of Otten Math.